Okay, so today in class we decided that the mean value theorem for integrals, that's this thing right here, we decided this is not on the exam. So this is not on the exam, but some people wanted me to make a little video with what it is anyway. So here is that video. And I want to start with a question, because I think it's always good to start with a question. Here's the question. Question. Is there anyone on Earth? Is there anyone on Earth who has the average number of eyebrows of all humans? Average number of eyebrows Okay, think about the answer. So pause the video and think. Is there anybody out there who has the average number of eyebrows? So think about yes or no. Is there somebody like that? And the answer is no. No. The answer is no. The reason is most people have two eyebrows. Some people have one eyebrow. Some people have zero eyebrows. That means the average is going to be slightly less than 2. So it'll be like 1.99 or something like that. And because you can't have a half an eyebrow, well, I guess maybe you could. Okay, we're counting like if you have half an eyebrow, that counts as 1, okay? So the answer is no, and the reason is because the average will be equal to 1.9, and everyone has an integer number of eyebrows, an integer number of eyebrows. Okay, so what is the mean value theorem for integrals? The mean value theorem for integrals tells you under certain circumstances the answer to this kind of question is yes. So for eyebrows the answer is no, but for other types of questions the answer is yes. So here is an example where the answer is yes. Question. Take all of the heights you have ever been in your whole life. Like when you were a little baby, you were like maybe this tall, and then you grew up. So now you're much taller. So you had different heights at different times in your life. So there's some average height, your average height over your entire life, and it's some height, right? Question: Was there a time when your height was equal to your lifetime average height? And the answer to this question, unlike the eyebrows, the answer is definitely no. This one is definitely yes. Okay, so what's different in this one? In this one, the heights are not integers. So eyebrows, either 0, 1, or 2 eyebrows, but your height is like this continuous variable, and it can vary. And not only is it continuous, it's been continuous over your whole life. So whatever it was when you were small, it's been steadily growing. So it's a continuous function. And the mean value theorem for integrals tells you that as long as you have a continuous function, there is some point where it's equal to its average. That's all the mean value theorem for integrals says. So the mean value theorem for integrals says let f be a continuous function on the closed interval ab. Then there exists some value of c such that f of c times b minus a is equal to the integral of a to b of f of x dx. And if you rearrange that, that says that f of c equals 1 over b minus a times the integral from a to b f of x dx. And this thing you'll recognize, this is the average of f on a to b. So the mean value theorem for integrals guarantees you that there is some point c where f is equal to its average. And if you apply that to the function, apply it to the function, your height function, to the height function, h of t, which is your height at time t, then you get for sure that there is some time where you were equal to your average height. So that's a fun thing. And the difference between this example and this example is in this one is continuous. And that is an important hypothesis on the mean value theorem for integrals. And in this one, it is not continuous. And that's why the answer was no. So not continuous. So this was a kind of a discrete thing, either 0, 1, or 2 eyebrows, but this is a continuous thing. What is your height? And maybe I'll say one more thing for people who like proofs. You don't see the big proof of the mean value theorem for integrals here, but it is quite easy to prove using what we've already done in the course. So maybe I'll add a little page here. How do you prove the mean value theorem for integrals? If it'll let me. Okay, we got a big arrow. What does that mean? Okay, here we go. How to prove And what you do is you apply the ordinary mean value theorem. So you're going to apply the ordinary mean value theorem. You're going to apply it to a function which you might recognize from the fundamental theorem of calculus. You apply the ordinary mean value theorem to the function a of x, which is the integral from a to x of f of t dt. So you might recognize this function from the fundamental theorem of calculus. This was the function in the fundamental theorem of calculus. This is the function where we know that a prime of x equals f of x by fundamental theorem of calculus part 1. And if you apply the ordinary mean value theorem to this function is definitely differentiable and continuous because of the fundamental theorem of calculus. And by the mean value theorem, if you apply the mean value theorem to this thing, you will get exactly this result. So the mean value theorem for integrals is what you get by applying the mean value theorem to this area so far function. Okay, so hopefully you enjoyed that little thing about eyebrows and your height. You can try to think of other situations where the mean value theorem for integrals applies or doesn't apply, but it tells you when is it true that the answer to the question, there is an element equal to the average of all the elements. When is that true? And the mean value theorem for integrals tells you as long as it's a continuous thing, the answer is yes.